Transforming chess piece puzzle. Overview. This is a simple chess-themed algorithmic puzzle, but you don't need to know anything about chess to solve it, other than 3 basic moves. The game is played between 2 players who take turns moving a piece on the board. Player 1 who always plays the first move, and player 2. The game takes place on a 5x5 board, and at all times there is only one single piece on the board. It is either a rook, a bishop, or a queen. Quick reminder, the rook can move horizontally or vertically, the bishop can move diagonally, the queen can move horizontally or vertically, or diagonally. The winner is the player who, on their turn, moves the current piece to any of the board's 4 corner squares. Gameplay is simple. After a player moves the current piece, they either win the game if they manage to move the current piece to any of the board's 4 corner squares, or if they do not win on the turn, the piece will automatically transform into the next piece according to the following repeating cyclic pattern, and the other player then takes their turn from the current position on the 5x5 board, which is this. Given the starting piece, rook, bishop, or queen, and the starting location for the piece, and assuming both players play optimally, your goal is to determine whether player 1 has a guaranteed win, a guaranteed loss, or if the game will become an infinite, never-ending guaranteed draw. For the purpose of this kata, playing optimally means that both players will attempt to win the game. If there is any combination of moves that will allow them to do so, and conversely will avoid any move that can lead to them losing. Inputs and outputs. You will be given a starting piece, which is a string representing the piece that is on the board when the game starts. One of 3 possibilities. R representing the rook, B representing the bishop, Q representing the queen. You will also be given starting row and starting column, both are ints from 0 to 4 inclusive. For example, starting row equals 0 and starting column equals 0 means that the piece starts in the top left square of the 5x5 board. We use standard array, row and column indexing to encode the 5x5 board as represented in the diagram below. You must return a string, win, lose or draw, depending on whether player 1, who always goes first, has a guaranteed win, lose or draw. Remember, to win the game, the current player just needs to move the current piece to any of the 4 corners, 0, 0, 0, 4, 4, 0, 4, 4. Examples. So this is the first example. In the above example game, the piece starts as a rook R, and in starting row equals 0 and starting column equals 1. Here, player 1 has a guaranteed winning strategy. The winning strategy is player 1 moves the rook from square 0, 1 to corner square 0, 0 or 0, 4 and immediately wins the game, without even letting player 2 play a single move. So the expected answer for starting piece equals R, starting row equals 0, starting column equals 1 is win. Right here. So this is the second example. In the above example game, the piece starts as a bishop, B, and in starting row equals 4, starting column equals 3. Unlike for the previous example, where player 1 had a guaranteed win immediately, here player 1 can't win immediately on the first turn. So player 1 needs to try to make a move with the bishop so that player 2 can't win when they take their turn, which will be with the queen, since that is the piece after the bishop. You should be able to analyze the various possibilities from here on. I'm not going to read this. Alright, let's start. Okay, time for my explanation. So this is a JavaScript function called transformingChess that takes 3 arguments: piece, row, col. The function uses a switch statement to check the value of the piece argument. Depending on the value of piece, the function returns either win, draw, or lose, based on certain conditions. For the R piece, which is the rook, the function returns win if both the row and col are odd, and draw otherwise. For the B piece, which is the bishop, the function returns win if the row and col are both even or both odd, and lose if the row and col are both odd or both even, but not on either diagonal, otherwise it returns draw. And for the Q piece, which is the queen, the function returns win if the row and col are both less than 4 and odd, and draw otherwise. And that's how I solve my puzzle.